Woohoo! Welcome back. Today we're going to be talking about matrices. Woohoo! So I've invited my friend and yours, Neo, to help us out with the fancy matrix calculations. Woohoo! So, what is a matrix? Basically, a matrix is a rectangular array of numbers. They do not have to be green. They do not have to be falling cool style or going up or down or anything. It's just a box with numbers in it. And in fact, it's just a box with numbers in it for us. It can actually be a box with a lot of other things in it. Doesn't have to be numbers. But that's where we're going to start. So we're going to start with a bunch of numbers in a box, and we're going to use matrices. Notice matrix is singular, matrices is plural, to collect the information from a system of equations to simplify the algebra usually required to solve it. Woohoo! And I'm going to say here that, no pressure, but many students actually see this as a good thing to not have to write the X's and Y's and Z's anymore. It allows you just to focus on the coefficients, and that does simplify things. It's also going to be really helpful because this is how we're going to teach calculators and computers to do the work for us. Woohoo! So let's hear for that. So the first thing we're going to talk about is you can have lots of different matrices, but we're going to be mostly working with linear systems and augmented matrices. So what does that mean? Well, an augmented matrix means you've made it bigger, and effectively we're actually going to combine two matrices. This linear system involves the matrix 3, 2, 2, negative 3, and the matrix 1, 5. And the reason for that is we've got the coefficients on the left and we've got the answers on the right, and they can be seen as two different matrices. A lot of times, to make it easier, we're just going to kind of smoosh them into a single matrix. Now, this is where things get weird. I'm not sure why, but the book that we are currently using when I'm recording this video does not follow the tradition, which is when you have an augmented matrix, you actually draw a line to kind of preserve the idea that there's, the left side and the right side, and then this is where the equals was. If you look there, there's the equals. The book leaves that out, and I'm not sure why. And I'm guessing it was hard to format, or perhaps the preference of the author. Not sure. It's really common to see them like this, but for the ease of doing the homework and reading the book and all of that, I'm going to go ahead and include the matrices in this form, no line. So just be prepared that in other settings you're going to see a line there, and it just represents the equals. Okay, so there's a lot of vocabulary. Let's get into it. Dig in. Come on. Woohoo. Well, we don't need to dig in. You just need to wrap the world around the vocabulary rather than... Anyway, something like that. So we're going to talk about the entries being arranged in rows and columns. A row goes horizontally like that, and a column is arranged vertically like that. And the way a lot of people remember this is that when you row a boat, you go horizontally, whereas columns hold up buildings. Woohoo! So columns are these guys that are holding up the building, so they're vertical, and rows, again, row your boat, you're rowing this way. Hopefully you're not going over a waterfall and rowing this way. That's more exciting, I guess, but probably not ultimately great for you finishing your homework. So, in addition to this, we're going to talk about the dimension of a matrix. That's basically the size. Effectively, matrices are about to be just, very exciting, considered kind of like really big numbers. We're going to start doing algebra with matrices. It's very exciting. And we're going to continue this. This is just an introduction. This continues in parts of calculus and then into linear algebra. And that informs lots of other parts of mathematics and, of course, computer science and engineering and all sorts of things. So, but we're going to describe the dimension, and that's the size of this matrix. It's going to be m by n, where m is the number of rows and n equals the number of columns. So this one right here, there are 2 rows. Here's row 1, here's row 2. And then there are 3 columns. So here's column 1, column 2, and column 3. And so this matrix is a 2 by 3 matrix right there. 2 rows and 3 columns. Okay, so that's the size. And it's going to be important for us to talk about the size of a matrix, the dimension of that matrix, so that we know whether we can do certain things with it when we get into the algebra. Next up, we can actually go in and identify each entry in the matrix by its row and column location. So 1, 1 means row 1, column 1. This is row 1, column 2, row 1, column 3. Notice that even if there's a line there or no line, we're still going to number them the same way. If they're in the same matrix, it counts. This is row 2, column 1, row 2, column 2, and row 2, column 3. One thing to point out, because if you're brand new to matrices, you might think, ugh, this is so hard. And in fact, it may be hard to see here. So let me exaggerate. In our column above, matrix above, I want to exaggerate. Make sure the edges of your matrices have these tops and bottoms. It may seem cool to just draw it as a straight line on each side, and it's certainly simpler, but that's going to represent something else. And one way to get a little preview is to think about what does a straight line, 2 straight lines around a number, that means absolute value. And so straight lines instead of these partial boxes is going to mean something else for a matrix as well. So do make sure that your edges of your matrices are kind of bent in like that. So it's like drawing the whole box, but you kind of got lazy in the middle. Okay, so a matrix, as far as we're concerned in this first section, is going to work just like a system of equations. So we've got something called elementary row operations, which are just like the things we were allowed to do with Gaussian elimination. And that is that we're going to add a multiple of one row to another, multiply a row by a non-zero constant, and interchange 2 rows. And we'll get practice with this. Okay, woohoo. Are you ready, Neo? Neo is ready. Let's do a problem. Woohoo! Here's the problem we want to solve. Okay, so sorry about that. We're going to use the same method we used in the last chapter, except now we're going to be doing it without the variables. Are you ready, Neo? Neo is always ready. First thing, we want to rewrite this as an augmented matrix. And again, I'm going to remind you, I'm going to follow the book's lead, and I will not draw the line, but you are welcome to do it. So I have to look at this first row, x minus y plus 3z equals 4, and I'm going to translate it as 1, -1, 3, 4. Next up, second row, I've got 1, 2, -2, 10. And then last row, 3, -1, 5, 14. Woohoo! Now, because this is not an interactive situation, I can't hear you if you're screaming or crying or gnashing your teeth. So if any of what I just did is like, whoa, you're not sure where those numbers came from, please pause the video. Go find me, which I know is weird because You'll be watching this when I'm not recording this, so I'll be available. I can answer your questions. Find a tutor, ask your friends, ask your family, stand on a street corner, ask passersby. You never know. There are lots of mathematicians in the world. You might find one. Definitely make sure you understand where these numbers came from before we go any further. Okay, so if you're continuing on, I'm going to assume this all makes sense. I'm also going to point out that if we were in any other book whatsoever, it would look like this. I mean, I guess instead, except all the books that this particular author wrote. So you can use either format. They will both work. And what we're going to do is I'm going to label them exactly the way I did before, row 1, row 2, row 3. And I'm going to follow the same procedure. Our goal will be that we can set up back substitution. So that triangular form we were looking for before. So I'm going to be looking for, okay, there's going to be stuff there. There's going to be 0, a 0, and a 0. Some more stuff, some more stuff. So I'm going to be looking for that bottom triangle of zeros. So I'm going to start with this 1, and I'm going to look at this 1 and say, what can I do to get rid of that 1? And just like before, I'm going to say, let's take row 2 and add the opposite or subtract row 1. And just like before, if I'm using row 2 and row 1, I can put this back in either spot. I'm going to put it back in row 2. So let's take a look. Row 2 is 1, 2, negative 2, 10. The opposite of row 1 is negative 1, 1, negative 3, negative 4. Okay, so take a look at that. I did it kind of fast. I'm multiplying by a negative, so I just changed all the signs. And then I'm going to add these together. And I'm going to get 0, 3, negative 5, 6. And this is going to be my new row 2. As you might guess, this is going to start to take some paper. So make sure you have a good supply of, whatever paper you like to use. If you're concerned, make it recycled. Use both sides. Maybe if you feel more comfortable, write smaller. You can even use a tablet or, something else electronic so you're not actually using paper. Use a write-on, wipe-off board, however you'd like to approach it. But you are going to have to do a lot of steps. Also, keep in mind that when you do a bunch of steps, there's a good chance you're going to make a mistake. So please, as you're going through, if things start to get frustrating or they don't seem like they're going very well, please stop and take a break and maybe ask for some help. Ask for another pair of eyes just to look over what you've done to see if they can see, oh, that should be a 5 right there. Okay, so I'm going to rewrite our new matrix. I've got my old row 1, I've got my old row 3, and I've got my new row 2. Okay, and I'm kind of too close for you to see everything, but remember the goal is the bottom triangle of zeros. Okay, next up, I want to then use this top number to zero out this 3. So I'm going to take row 3 and I'm going to subtract 3 times row 1 and put that back in row 3. So row 3 is going to be 3, negative 1, 5, 14. Negative 3 row 1 is going to be, now this one's a little bit hard, so you might want to take your time. There's a lot of numbers. Negative 3, positive 3, negative 9, negative 12. And again, if you're looking at this going, what the what? Where'd those numbers come from? Stop, pause the video, go find me. I will help you. Find tutors, ask a magical frog. And if you don't have a magical frog, ask a magical cat, So, ask Neo. I'm sure he knows lots about matrices. Okay, I'm going to add, I get 0, 2, -4, 2. So far, so good? Okay. So I'm going to have to switch on to the next page. Let me kind of scooch it right there so you can see what I'm doing. My new matrix. And again, you don't have to rewrite the matrix every time. I do just to make it a little easier. I've got 1, -1, 3, 4, 0, 3, -5, 6. And this is going to be my new R3, row 3. So it's going to be 0, 2, -4, 2. Okay. And I rewrite it every time just so I don't get lost. You do not have to do this. There are going to be a lot of different styles. A lot of different folks have different styles, how they actually approach all of these. So, come up with a style that you don't hate, because you're going to be doing a lot of these. Now, I'm going to do something interesting. There are a lot of things we could do right now, but you'll notice that I actually want to put a 0 here, right? Sorry, I'm blocking right there. This number is 3. Using a 3 and a 2 to make a 0 is not impossible, but it's not my favorite thing in the world. So I'm going to show you kind of a cool trick using some of the other things we're allowed to do with matrices. So I'm first going to go ahead and I'm going to look at this row, and I'm going to take half of row 3 and put that back in row 3. What does that mean? I'm dividing by 2. So my new matrix is going to be 1, -1, 3, 4, 0, 3, -5, 6, 0, 1, -2, 1. So far, so good? Woohoo. Okay. Next thing I'm going to do, I'm going to swap row 2 and row 3, which is something we're allowed to do. Oops. That's ugly. And so then I'm going to rewrite this. 1, -1, 3, 4, 0, 1, -2, 1, 0, 3, -5, 6. Now, do I have to do this? No. But I am showing you how to do elementary row operations to solve a matrix. And so I'm going to do it properly the first time. There are a lot of shortcuts. There are a lot of other choices you could be making. And once you get some practice with this, you'll start to see that, oh, I didn't have to do that after all. But this is the very formal, perfect way of doing it. So we'll do it that way. Okay, now I'm going to go ahead and use this 1 to get rid of a 3. It is always easier to use a 1 to get rid of a number than to use a 3 or a 2 or another number. So that's why I set up 1s in the diagonal. Okay, so this is 3. So I'm going to take row 3, and I'm going to subtract 3 times row 2 and put that back in row 3. So that's going to be row 3, 0, 3, -5, 6, and -3 row 2. That's going to be 0, -3, 6, -3. Right, -3 times 1 is -3, -3 times -2 is 6, and -3 times 1 is -3. So I get 0, 0, 1, and then 3. So my new, let me scooch this up. My new matrix looks like 1, -1, 3, 4, 0, 1, -2, 1, 0, 0, 1, 3. Because this is my new row 3. And now we are able to very simply go ahead and use these to solve. So from this row, I get z equals 3. From this row, I get y minus 2z equals 1. And from this row, I get x minus y plus 3z equals 4. So if I get another piece of paper, I can use back substitution. I can use back substitution to solve. So z equals 3. Woohoo. And then I've got y minus 2z equals 1. So y minus 2 times 3 equals 1. Y minus 6 equals 1. So plus 6, y equals 7. Okay, nice. And then I also have x minus y plus 3z equals 4. Is that correct? I want to double check that. X minus y plus 3z equals 4. Yay! So then I get x minus 7 plus 3 times 3 equals 4. X minus 7 plus 9 equals 4. X plus 2 equals 4. Subtract 2 from both sides, and x equals 2. So my answer, oops, you can't see it, is 2, 7, 3. Now, I would love to say, and we're done, and we can just stop, and there's nothing else. But what does Neo say? Neo says you always need to check to make sure it's safe, right? Okay, so how are we going to check? Well, we've got these original equations. They're going to go really fast. We just have to check the original equations. So the first equation, x minus y plus 3z equals 4, is going to check because we just did it right there. But let's check it again. 2 minus 7 plus 3 times 3. Is that equal to 4? And the answer is 2 minus 7. Oops. It's only quick if you don't write a different number than you're saying. Does 2 minus 7 plus 9 equal 4? And the answer is yes. So that would be, I mean, depending on how you do it, you could either do 11 minus 7 is 4, or you do 2 minus 7 is negative 5 plus 9 equals 4. Yep. Our second equation was x plus 2y minus 2z equals 10. That would be 2 plus 2 times 7 minus 2 times 3. Is that equal to 10? 2 plus 14 minus 6. So that's 16 minus 6. That equals 10. Yay. And then the last equation, this is row 1. This one was row 2. Let me see if I can get row 3 squished in here. 3x minus y plus 5z equals 14. Does 3 times 2 minus 7 plus 5 times 3, does that equal to 14? So that would be 6 minus 7 plus 15. Does that equal 14? It does. Woohoo! So we did this one correctly. Yay! So this is basically what we're going to be doing for the rest of this section. In the next video, we're going to look at a couple other examples, do a word problem. It's going to be super fun. So go get something nice to drink, go get a snack, you know, stretch your bones and your muscles and your eyes, give your eyes a rest, and then come on right back. Join me again. We'll have some more Matrix fun. Woohoo! Dance party. Okay. Woohoo! Math on.